Hello friends, today I am going to discuss about the Orgel diagrams brief discussion. So first of all, Orgel has divided the D10 configuration, D1 to D10 configurations into three sets. One is D1, D6, D4, D9, D2, D7, D3, D8 and D5. Okay, three sets he has divided. So before we going to know about the Orgel diagrams, 3 points to be noted. D and D5 plus N configurations will be called as normal configurations and they will have same type of diagrams. And D and D10 minus N configurations will called as whole reverse configurations, and these configurations will have inverted type of diagrams, that is reverse diagrams. And in crystal fields, octahedral and tetrahedral, the splitting diagrams will be inverse to each other. So the first set D1, D6, D4, D9. Ground state term for all these four configurations is ND, and N equals to 2 for D1, D9 and N equals to 5 for D4, D9. So if you see the diagram, so it is the splitting diagram, which is lower energy level is 2 to T2 to G to EG. Okay, it is for D1 octahedral. So that Dn plus 5, that is D1 D6 octahedral will have the same diagrams, where for D1 n equals to 2 and where for D6 n equals to 5. And this D1 D6 octahedral diagram will completely reverse for D4 D9 because whole reverse configurations, right? So D1 D6 octahedral will applicable for D4 D9 tetrahedral, same T2G to EG transition. So its reverse splitting diagram is applicable in if it is for D1 D6 octahedral and this one is D1 D6 tetrahedral. Okay, if it is D4 D9 tetrahedral and this one is D4 D9 octahedral. So by reminding this diagram, we can write the transitions for four configurations. Second set of electron configurations are D2, D7, D3, D8. The ground state term for all these four electron configuration is N of Np, where N equals to 3 for D2, D8, so triplet F, triplet P, and N equals to 4 for D3, D7, quartet F, quartet P. So if you see the diagram, so this is the diagram for D2, D7, D3, D8 electron configuration. So the right side diagram is the lower energy level is N1T1GP, NT2G and A2GF, and this energy level is from NT2GP. So this diagram is applicable for D2, D7 octahedral. So D2, D7 whole reverse configurations are D3, D8. If it is D2, D7 octahedral diagram, so it is D3, D8 tetrahedral diagram, right? So that possible transitions are NT1GF to NT2GF, NT1GF to NT2GF, NT1GF to Na2GF, NT1GF to NT1GP. Three transitions will occur. And if it is D2, D7 octahedral, the reverse diagram is D2, D7 tetrahedral, right? So octahedral, tetrahedral will have reverse splittings, right? So the higher energy level will be the lower energy level here, right? So the lower energy level A2GF and next T2GF, next T1GF and next T1GP. Here three transitions A2GF to T2GF, A2GF to T1GF, A2GF to T1GP. So by reminding this diagram, we can write the D2, D7, D3, D8 configurations, octahedral and tetrahedral splitting diagrams. Here one thing to be noted, when we writing the electronic transitions for octahedral complexes, we have to write the transition as T1GP to T2G, T1GF to T2GF. But when we writing the splitting diagram for tetrahedral complexes, we should not write the G subscript because tetrahedral complexes are not having the center of symmetry. So we should skip the G subscript. And it is for D5 electronic configurations. So mostly for D5 electronic configuration, the ground state term is 6 state S, and the next energy level will be quartet G, quartet P, quartet D, quartet F. So no allowed transition is here because spin multiplicity is different between the energy levels. So spin forbidden transitions will possible in D5 configurations. So 6 terms will split into 6 state S will split into single energy level 6 state A1G. Quartet G will split into 4 energy levels like this, and quartet P will splits into T1GF. So here one thing to be noted, when the energy levels with the same symmetry approaches together, the symmetry will be distorted, right? So hyperbolic curve will be observed here. Okay, so here also symmetry is deviating, the energy levels will be deviating in the symmetry. This is about Orgel diagram.